You wake up, you go outside, you see what you see. The next day, you go outside, you see that same thing again. The day after that, you wake up, you go outside, and you see what you see. Is that what the world seems like to these critters too? Minus the go outside part. They have that covered. But, unless something dramatic happens, does the outside world seem like a relatively static and unchanging place? Well, guess what? It's not. The outside world is a dynamic place, but unless there's an immediate change like a natural disaster, sometimes you have to look on a different time scale to see the change. Let's take UC Santa Cruz for example. When you look at this aerial view, what things pop out? Can you see the city of Santa Cruz? Grassland and forest? Minus the city, has it always looked this way? Yeah, no. But let's not get that deep. Let's look instead at how vegetation communities here at UCSC have changed over a more reasonable timescale, about 170 years. Note that this video doesn't focus on the thousands of years of active land management practiced by the ancestors of the Amamutsan tribal band, though that's a deep and complex and really important topic. This map shows vegetation communities mapped by consultants in 2002. Different types of forest, grassland, and a few smaller patches of northern maritime chaparral, a shrubland habitat. Zooming into the western, mostly forested part of UCSC's upper campus now. This will be our study area for the day, and the set for our landscape change mystery. An aerial view from 1991 shows the forest as a darker color, with chaparral appearing lighter in the upper center of the photo, with some even lighter bare patches visible too. Jumping ahead to 2018, we see the land more or less as it is today. Do you notice any other changes that occurred in the intervening 27 years between these images? Check out that rectangular patch of chaparral at the upper center. Some kind of disturbance created a change in the habitat. Jumping even further back, we reach the time of Davis and Jordan and Henry Cowell in the lime industry. Marble bedrock, itself signifying massive change, as it's really calcium carbonate or dead sea creature shells and exoskeletons, and here it is on dry land. But anyway, this marble was quarried from what is now the campus, burned in massive kilns to produce a pre-cement building material called lime that helped build California during the gold rush. Where did they get the fuel to burn in these kilns? You guessed it, the forest. Within a 50 to 70 year period, everything worth burning in the kilns was cut, and that was basically everything. That was the first major disturbance the industry had on the land. The second was fire. In order to haul trees, you need to cut off the branches and buck up the trunks. The stems are too cumbersome to haul, and they burn too quickly, so they were piled as slash and burned. And unsurprisingly, these fires often got out of control. It's thought that the whole interior portion of the Santa Cruz Mountains burned over a few times during this period. Our job today is to figure out how the forest recovered from these two disturbances of logging and fire. We'll do that by examining the process of succession as it played out here on what is now the UCSC campus, and thereby get a glimpse of landscape change. Primary succession starts from bare rock, as what might happen after volcanic activity. Although there were volcanoes here in the distant past, what we're dealing with is secondary succession, where seed source is available on site, in the soil and from nearby trees and other plants. Watch the wee little arrow as it traces the scene of our investigation. We'll be tracking landscape change in a blob mostly north of the north perimeter parking lot. What will we discover? How is the vegetation recovered from large-scale deforestation and fire? We'll make some observations and then try to interpret those observations to tell this story of change over time. You'll be the nature detectives, hunting clues and piecing them together. To simplify this task, let's pay attention to just 5 of the many plant species out there, 4 trees and 1 shrub. As we explore the area, we'll be looking for them in all states and sizes, alive, dead, large diameter, small diameter, seedlings and saplings, or barely recognizable skeletons of their former selves. To do this, it's helpful to know what these things look like, what conditions they prefer, and what they're capable of. So grab your detective notebooks and let's go. Now that we've gotten to know our main characters a bit, let's track them through a series of scenes from our study area. Jot down notes on your worksheet, and later you'll have the chance to interpret these observations as you try to tell the successional story of landscape change.
The case called for some old-fashioned detective work.
To keep it at a slow enough pace to make your observations, we strap cameras to the backs of several volunteer banana slugs. Look for interactions between the main characters and describe what you see.
Follow me. Another clue? the biggest peninsula I've ever seen.
Exhausted but exhilarated from your exploration, it's time to take your detective pen and tap it against your detective head and put together the pieces. Hit pause and try to synthesize your observations. What conditions do each of those 5 species prefer? How are they able to reproduce and respond to disturbance? What changes do you think occurred, and what evidence do you have? What happened soon after the disturbance, and then what happened after that? Who's on first? I don't know. So again, here's where we were. And again, here's what happened. And here again is the Vegetation Communities map produced in 2002, this time with labels. Dwarf redwood forest, the densely packed small diameter redwoods you saw in some prior clips, chaparral forest transition, and dwarf redwood mixed chaparral all represent communities in transition to one extent or another. These are the areas that clearly show succession post-Cal Ranch disturbances. Lumping these transitional zones, in addition to some areas mapped as redwood forest but clearly showing signs of transition, and simplifying the map overall, we can see what the area might have looked like following the lime industry's logging and fire. Note that in this exercise we didn't encounter coastal prairie. The thought here is that clear-cut logging opened up the forest canopy, allowing in the sunlight that chaparral plants like brittleleaf manzanita thrive upon. Add in the fire, which most chaparral plants are adapted to, and you get conditions ripe for chaparral expansion. Now, in the nearly present, you can see how the chaparral has receded as the forest has reestablished itself. But what's our evidence, and how do we think this happened? Let's briefly glance back at some clips of our explorations. We know that redwoods stump and root sprout following logging. We see stumps all over Science Hill, for example, with rings and other patterns of second-growth trees surrounding them. But here we have redwoods without stumps. How'd that happen? Perhaps these stands, labeled on the 2002 map as dwarf redwood, are the result of fire clearing away the leaf litter layer and exposing sandy mineral soil, where redwood seeds were able to establish and grow into these dense but somewhat dry and nutrient-deprived stands. And then how about all the dead brittleleaf manzanita in these stands? Well, it seems that this was an area in which chaparral grew following logging and fire. What was there prior to the disturbances is another mystery, but it doesn't seem like it was redwoods. No stumps. Now how about these larger diameter Douglas firs with large lower limbs, often with skeletons of dead manzanita below them? These aren't much older than the skinny dwarf redwoods, surprisingly.
I'm as tall as a tree.
It seemed that winged seeds from existing, as yet uncut Doug firs blew into existing or advancing stands of chaparral and found a nice place to settle down and grow up. Able to grow in the shade below the dense shrub canopy, the Doug firs had all the sun they wanted after emerging above this canopy. This allowed their lower limbs to grow large and outwards, which ultimately shaded out the shrubs below and started the transition back to forest. The standing and fallen dead madrones tell a similar story to the manzanita skeletons. Madrone also likely established in open sunny zones following logging and fire. perhaps dispersed there from birds eating the berries and pooping out the seeds. Ultimately, though, they weren't able to withstand the shade provided by the redwoods and Douglas fir that established within the shrublands and outpaced the sun-loving madrone and manzanita. The dead knobcone pines in certain areas of the forest point to a history of fire, as the knobcone needs fire to reproduce. This early successional species is relatively short-lived and easily overtopped by the taller conifers that established later. Finally, we saw redwood stumps and second-growth resprouts along the tributary stream leading down to Cave Gulch. These stumps tell us without question where redwood forest grew prior to the lime industry disturbances. Redwoods like these lower, wetter microclimates, like in this narrow ravine, which also happen to be among the few places in our study areas where we don't see dead manzanita. Seems it was, and still is, forest. So to put it more simply, disturbance, expansion of chaparral, shrinkage of chaparral as forest reestablished. The cool thing about this is that we can look at today's chaparral and see the same dynamics happening. Here we have the dense, impenetrable shrubland. Impenetrable unless you crawl, that is. Here are the living burls of the brittle-leaf manzanita. It's also a good place for conifer seedlings to establish, if the seeds can get here. And now, as then, we have Douglas fir and redwood towering over the chaparral. And then, below the Douglas fir, the sun-loving shrubs get shaded out. Same dynamic as before, happening right now. Now might be a good time to point out that I don't really know what happened out there. In lieu of specific photos or written records, this is just based on what I've observed out there. Hit pause if you want to read the gist of it.
By George, I think you've got it.
There are a couple of successional models evident here. Facilitation, where the manzanita created and is still creating the conditions that allow the conifers to establish, which leads to a later stage in succession. And inhibition, where currently many of the shady redwood forest stands are preventing much else from establishing, until another disturbance comes in, that is. If we're not logging, and if we're suppressing wildfires as much as we can, what will this disturbance be? Could be disease, as we're seeing regionally with tan oak, or it could be intentional. In February 2018, we worked with CAL FIRE to burn 2 8-acre patches of chaparral on Upper Campus. Our original intent was to take out the Douglas fir and redwoods and thereby prevent chaparral from transitioning to forest, but we hit some red tape at the last minute and couldn't take the trees out. The shrubs, however, got roasted and are regenerating quickly. Annual and low-growing perennial plants that hadn't grown in decades had their chance to germinate and set seed, replenishing their stock in the seed bank for their next appearance following the next disturbance. 2 manzanita species, the rare Santa Cruz manzanita, which comes back from seed, and the brittle-leaf manzanita, which resprouts from its basal burl and sprouts from seeds, are coming back strong. You may have noticed a senior thesis student's poster in the last clip. We have 2 other projects at UC Santa Cruz where we're tracking long-term landscape change dynamics. The Forest Ecology Research Plot, or FERP, is part of a global network of forest plots studying long-term forest dynamics. The 40-acre FERP was established in 2007, and every 5 years we remeasure all of the 40,000-plus woody plant stems that are bigger than your pinky finger in diameter to track growth, mortality, and recruitment. The FERP is a hub for ecological research of all kinds, and it's a training ground for future ecologists, serving nearly 100 interns per year during census years. The Continuous Forest Inventory Project is a newer effort that tracks long-term dynamics on a series of circular plots throughout UCSC's Upper Campus. Repeated measurement of various vegetation and ecosystem parameters on these projects will help any future nature detectives in their efforts to make interpretations of the landscape around them. It'll make that effort thoroughly quantifiable, if that's your thing. If not, you can always slow down, notice your surroundings, appreciate the beauty, and remember that it's all in flux. Nothing in this wild world ever stays the same for long.
Bye-bye, see you in a tree. Just kidding.